My name is Matthew. I'm a hobbyist iOS app developer, and today I'm going to be talking about MapKit and SwiftUI. But before we start, let's talk a bit about myself. Who am I? I'm actually not an iOS app developer by trade. It's not my job. Actually, my real job is a physicist. I work at a major university here, and I don't really do programming in my day-to-day life. But I'm an app developer out of spite. What do I mean by that is that I have one app on the App Store. It's 100 Bus. It is a bus arrival timing app. And I know what you're thinking. There's like, oh, there's 5,000 of those on the store already, right? And you're correct. There are so many of those on the store. But I realized that all of them not very good. Is there anyone here who has an app on the store that does bus arrival timing? If you do, right, means I haven't tried it yet. So later after the show, you come talk to me and show me your app. Because if you're sitting here, means you know a bit about design and app development. But anyway, those that I've tried are not very good. So you know, it's all the things that we like to chastise here. It's things like cross-platform frameworks, you know, like technology-centric design instead of user-centric design that makes the user experience not very good. So I started learning how to build iOS apps in July of 2021, and then I released this in May of 2022. Yeah, so I'm quite proud of that. But I'm not here to talk about my app. I'm here to talk about this part here, this on top 60% here, which is the map part of it. Okay. I use a framework released by Apple. It's called MapKit, and it has a lot of features actually. Obviously, you can embed maps into your app. You can add annotations and overlays. So this is an example from my app. You can see this dot here represents the bus stop, and you can plot the arriving buses that are going to arrive at your bus stop. And then this green line here is an overlay that shows the routes of the buses. So you can do all of these things in MapKit. You can show look around, which is Apple's answer to Google's Street View. So you can see your destination before you get there. You can respond to user interaction as well. So when you click on the map annotations, they will inflate, and then your app can be notified and perform whatever tasks. You can provide local search as well. So if you search for Apple, you can get like their retail stores, their developer center, and their corporate headquarters, for example. And it provides turn-by-turn directions as well. Okay, so all of these are free features that are provided by Apple in MapKit. I'm surprised that more apps don't use these features because it's free, there's no licensing, and in my opinion, it is much easier to use than a lot of these other SDKs provided by other vendors. Okay, but today we're going to be focusing on a subset of these features because I think we're running a bit long today. So how do we embed MapKit into our apps? So I'm going to be talking today about apps with the SwiftUI lifecycle, but MapKit comes in two variants. It comes in the UIKit version and the SwiftUI version. And when I talk about the UIKit version, right, just pretend that I'm talking about embedding a UI view into a SwiftUI view hierarchy. So how do you do that? What you need is to create a struct that conforms to the UI view representable protocol. And then to conform to that protocol, you need to add a few functions. So this one is make UI view and update UI view. You need both of these whenever you conform to this protocol. And when you want to create a map, you just return an MK map view inside the make UI view. This function doesn't really do anything, but we need it to make it work. Okay. This actually works by itself. If you just have this, you can see a map already, but it's not very good because you can't really respond to user input. So the way that SwiftUI handles dealing with UI views is you have to implement something called a coordinator. And if you are from UIKit, there's also something else that's a coordinator, but that's a completely different thing, so don't think about that. This coordinator is a MKMapView delegate that UIKit uses to inform your SwiftUI app what the user just did. If you want to go a bit more complicated, if your app is a bit more advanced, sometimes you need to add a map manager here. And in this class here, you add things like, oh, I want to add my annotations, I want to like customize them, or if I want to communicate with other parts of my application, you will put all of that logic here. But today we're going to be a bit simple, so we're not going to do that. This is just the part that we're going to focus on, okay? So yeah, this is the UIKit version of how you would implement a MapKit app inside your SwiftUI app. So how would you do something like this in SwiftUI? Okay, first of all, you need a struct that conforms to the view protocol, and then you have a body property. What do you put inside the body property? Instead of talking about that, let me just give you a demo. Okay. So over here, I have a SwiftUI app, and it has right now just text that says map, which is not very interesting. What we want to do is put a map inside. So actually, if I can do this one-handed, to put a map inside, you just type MAP. That's it, that's all you need to do. If you're on SwiftUI, all you need to do is type these 5 characters. Well, okay, you also need to import MapKit. But once you've done that, you just type MAP, and then you have the map here, which is much easier than all that stuff that we have to do over here, right? Okay, but this is, this is a real map, by the way. This is like a fully interactive. You can scroll around, you can zoom in, you can rotate, if I can do that one-handed. Yeah, all of this is provided for free by MapKit. If you want to add annotations, this is probably what you want to do, right? If you have a map. So in UIKit, what do you do? First of all, you need to define the data model that hosts all the data for the annotation. So over here, I have a class that conforms, that inherits from MK point annotation. And because it's a class, I need an initializer. Okay, so in every MK point annotation, you have a coordinate, a title, and a subtitle. Okay, this is all stuff that's provided for you in this superclass. And let me just go ahead and add some sample data here. So these are just a bunch of bus stops that are nearby. You have the church, which is right outside, ORQ, Dhobi Ghaut, Bishan. And, oops, sorry. Hold on, this part I have to do. We'll come to that later. Okay, so let's go ahead and add this sample data to our app. So over here, inside our MK, in our make UI view, after I create the map view, all I have to do is add the part that tells the app to add the annotations. Okay, so I just say for each annotation, just add. Okay, so there you see it. See, there's Bishan station up here. There's the 3 other bus stops that we have here. Okay, so again, this is fully interactive, and you can see, can you see? Once you click on the annotation, there's the subtitle will appear. Yeah. And I defined the subtitle over here. Yeah, I set the subtitle to be the bus stop code. You can customize it to whatever you want. Okay. Another thing I like about MapKit that other SDKs don't have is that it does text collision detection. So for example, you see here, can you see? Singapore River is a big word, but if I zoom out, right, you can see that it disappears so that it doesn't collide with the text of the map annotations. Yeah. And this happens to all of the other annotations that are provided in MapKit. So you see on top, Dhobi Ghaut station, the text will disappear once it's about to collide with the other bus stop. And again, you get all of this for free with MapKit. Okay, but this is not very nice, right? It's just a pin and a red color pin. So what we want to customize it, right? We want to add our own branding. So what we do is inside our MK map view delegate here, we add a new function. It's called a map view view for annotation. So what this delegate does is that it will give you an annotation, and then it will ask you what view should I render for it. And so the problem with this is that it will give you literally every annotation inside your app. So you can have different kinds of annotations, like for example, you can have a bus stop annotation, or a taxi stand annotation, or a car park annotation, and they're all different, and you want them to be rendered differently. So what you have to do is to switch across the annotation that they give you, and you do a case let. As, okay, stop annotation, like that. So in whatever you write here, this will return the view, or the MK annotation view, that is expected of any kind of bus stop annotation. Okay, I'm not going to write that down because it's a lot of code, as you will see. Oops. Just a bunch of code. So for those of you who are familiar with UIKit, this will not be very foreign to you. You just create the annotation view, and then you just assign all of the properties for it. This part here is quite interesting, this dequeued view thing. This one is a piece of code that will help MapKit be more efficient. Because once you render a view, which is like one of these annotations, all of the other annotations that are exactly the same, you don't have to keep rendering them over and over again. So what this code does is that it tells MapKit, okay, everything that is a bus stop annotation is the same view. So it can just take that view and copy it over and over again instead of rendering it and wasting CPU cycles. Default. Okay, so now it should run. There we go. You can see that our bus stops now have a teal color and with the UI image of the bus. That's great. If you want to customize the, what's this called, the cluster annotation, you can as well. Let me just copy this. Okay, so now I set it to a blue color and white text, which we have here. So yeah, all of this is very easy in UIKit. Well, it's very wordy for sure, because it takes up the whole screen, but it is very, it's not very difficult to do. How do we do the same thing in SwiftUI? So over here, the map initializer in SwiftUI is very similar to what you have in like other view builder collections in SwiftUI, like vstag, list. All you have to do is create a trailing closer like this, and from here you add all of the markers that you want. So you just type in marker, and you have an initializer like this. So you have the title, image that you want to display on top of the annotation, and the coordinate that you want to put it at. Okay. So over here I have some sample data, which is the same thing as what we had for our MK point annotation, but in SwiftUI it is a struct, and there's no protocol conformance that you have to follow. I use identifiable here because usually in SwiftUI, whenever you have data, try to conform it to identifiable so it's easier to work with. And so that's what we will be doing now. So I'm going to run some, for those of you who are familiar with SwiftUI, this will be quite familiar to you. For each, I iterate across all of the bus stops that I have, and I just create a marker for all of them. Okay. And this should work. Ta-da! You see it here. So if you want to compare to UIKit, you need all of this and more on top. But in SwiftUI, it's just that. So it's much easier to do. And but something that you note is that when you zoom out, you notice something? There's no clustering. So in SwiftUI, MapKit for SwiftUI, there's no clustering. So you don't get any of like the joining together with the nice animation. The bubbles will all overlap with each other. Right now in SwiftUI, there's nothing you can do about it, unfortunately. Yeah. Okay, I see like this map is kind of noisy, right? It's like the green and the blue and all of the road names. So how do we customize it to really highlight the things that we care about, which are these map markers? So in SwiftUI, all you have to do is, which is really like for those of you who are using SwiftUI, this is very familiar to you. All you have to do is create a map style modifier, and let's create, what do we want? Standard, maybe realistic elevation, muted emphasis. This is the one that I care about because I want to tone down the color. I don't care about any of the points of interest, and I don't want traffic. So yeah, you get something like this, which is much nicer to look at, and it's very easy to do. In UIKit, how do we do this? We come up here, so when you create your map view, you have to create a configuration and then apply that configuration to the map view. Okay, so you create a configuration, you do all the, set all the properties that you want, and then you set it as the preferred configuration. And in UIKit, you get the same thing. See? In both cases, they look great. Okay, something else we want to do is we want to react to changes in the map. So for example, when I click on this, maybe I want my app to display a pop-up or something else to happen. How do we do that? Again, it's in the delegate callback. So what do we do is create a new function. This function is called mapViewDidSelectAnnotation. So what it will do is it will pass you an annotation, and okay, you go handle it. So it will tell you, okay, what annotation did I get? If I got a bus stop annotation, let's do something. If I get a cluster annotation, let's do something. You can also add other cases, like if the user taps the user location, you know, the blue dot, you can do something. There are other callbacks. For example, if the user pans around to a specific location, do something. There are a lot of things that you can do here. So, okay, I can't actually do that here in the preview, so let me just run this. Can I run this? Yes. And let's see what happens. Oh, I'm not on Wi-Fi right now. So, okay. Oops. Anyway, this still works though, if I ignore all the failures. If I click on this one, it says here, selected annotation. If I click away, it says deselected annotation. Okay, how do we do this in, this is how you do it in the UIKit version. How do you do this in SwiftUI? Again, if you're familiar with SwiftUI, what we do is we create a state property here called selected bus stop, and this is a string because that is the type that we use as the identifier. So if you use an integer, you use int. If you use a UUID, you use that. But in this case, I happen to use a string as my identifier, so I shall use a string as the type here. And when I instantiate the map, there's a different initializer that I use, which is this one. So I give it a binding to the selected bus stop state property, and from there I will be able to tell what was selected. So let me change to the SwiftUI view and run this. Oh, nothing will happen yet because I haven't added the property. Hold on. So again, if you're familiar with SwiftUI, this is an onChange modifier. So when this property changes, do something. So when the selected bus stop string changes, if there's an old value, it means it was deselected. If there's a new value, it means something else was selected. But the problem with SwiftUI in this case is that it will only pass you the identifier. Unlike in UIKit, it will pass you the annotation, which has a lot more information, things like the coordinate, the title, subtitle, and any other properties that you set. But in SwiftUI, it will only give you the string. So if you want to do anything with it, you have to perform a lookup. This is a very rudimentary lookup that I did, just iterate through and select the first one and print the selected bus stop. So if we run this, it should work. So this is just something that you have to take into account now if you use SwiftUI. So again, you select Adobe God, Armenian Church, One Raffles Key. Okay? Yeah, I didn't implement the looking out for the deselected value here. That's why you only get the identifier. Okay, now something that most apps do is that when you click on one of these annotations, you will zoom into the location, right? Because that's probably what you want to do. In UIKit, how do we handle that? In UIKit, all we have to do is we have the map view, and we just run the set region property. So for example, over here, when you select the annotation, we have the map view, which is given to us by the delegate callback. We run the set region method with whatever position that we want. There are different methods that you can call. There's set region, there's set map box, there's set camera if you want to do the angles and stuff. You can do all of that. But I use set region because it's easy to use, because you just specify the center and how much you want it to be zoomed in meters. Okay, so if we run this in UIKit, if you tap on something, it will zoom in. Yeah, it will zoom in. And if you tap on something else, it will center. Okay, how do we do this in SwiftUI? It's very similar, again, inside the onChange modifier. Over here, no, not yet. We set the camera position, which is a new state property that we initiate or instantiate. The camera position, we set it to automatic in the beginning so that it will zoom to the appropriate zoom level in the beginning. And we set the camera position once we select a bus stop. And also something else we need to do is to change the map initializer. So now we also specify, in addition to the selection, the camera position as a binding. So once that's done, when you click here, you will zoom in. Now notice something different here. There's no animation. It immediately jumps to the next position. How do we fix that? If you're familiar with SwiftUI, again, you use a with animation closure. It's so easy. You just tap and you zoom in. All you have to do is add a with animation closure. If you want, you can add the property here to, sorry, not the property, the animation function here to this binding if you want. You can do that as well. Okay, so that's mostly what I want to share with you about SwiftUI and MapKit. There's just one more thing that is a bit problematic that I find, is that it's about the performance. So SwiftUI is a very new, SwiftUI for MapKit rather, is a very new framework. It was vastly improved. It was introduced in iOS 14, I think, and it was vastly improved last year. So most of the things that you see here weren't even possible 2 years ago. But it still has some of its limitations. So for example, I have here this bus database file here, and all this does is just import all of the bus stops in Singapore. You don't really need to care about this, but it's just, yeah, importing all of the bus stops from Singapore. So there are around 5,000 bus stops in Singapore, and let's try giving SwiftUI all of the bus stops, okay? I know we all want to go home, but we have to wait until this finishes. Any second now. If you look at the CPU here, can you see it's 100%? And we're using a lot of RAM. Wait for it.
You number the bus stop, or you can just put Northern Village?
We can number them if you want. Yeah, but I happen to have all of them here. Oh, it's done. So again, the problem is there's no clustering, so all of the bus stops just appear. And if you tap on one, it's not gonna. Yeah, like if you can see the CPU here, it's 100%. So it's not very efficient. And if you have 5,000 bus stops, oh, we selected. If you have 5,000 bus stops, your users will not have a good time. So let's not do that. Let's try doing the same thing in UIKit. So instead of importing the samples, let's import all the bus stops. and we see what a difference clustering can make. Let's run this. There we go, it's done already. So you see all of the bus stops here. Okay, I know it doesn't look done because I'm not connected to Wi-Fi and the map doesn't look like a map. No, never mind. Yeah, but all of the bus stops are here. If you click on one, it will zoom in quite smoothly. I mean, if you could render the map. Maybe I should, I have some map. This is a cache. So yeah, I have all of the bus stops here, and they're all visible. If I zoom in, you can see all of them. Again, all of this clustering is available for free. I didn't do any clustering here. Well, apart from like designing what the cluster looks like, I didn't do anything related to clustering here. It's all handled by the system. All the collision detection, distance detection is all done by the system. Okay, so that's all really I wanted to talk about today. Before we finish, let's do a brief recap about what we learned. This is how on the left, you have what you need to do something like that in UIKit, and on the right side, you have SwiftUI. So you can see it's a big difference. For the annotation data model, what do you need to specify when you create an annotation? On the left, you have to inherit from MK point annotation, and from the right, you just create a struct, any struct that you want, and then you use the for each loop to say what properties you want to plot where. Okay, to define what the annotation view looks like, again, on the left side, there's a lot of UIKit stuff. You just create the thing, and then you assign the properties of the thing. On the right side, you just create the thing itself. If you want to change what the map looks like, on the left, you create a configuration struct, and then you assign it to the map view. On the right side, you just you just add a dot modifier to the end of your map view. How do you handle user interaction? On the left, you have delegate callbacks, and on the right side, you have onChange modifier. And how do you change the camera view? On the left, you set the property directly by calling the setRegion method of the map view. And then on the right side, you just change the state property. Okay, there are some differences, as I've alluded to earlier, about UIKit versus SwiftUI when it comes to MapKit. So again, one of the things that's missing is clustering, and this will cause a very large degradation of performance as you've seen. Some other things is geodesic polyline. This is not available in SwiftUI yet. If you've seen, for those of you who don't know, the Earth is round, and because the Earth is round, straight lines on the Earth's surface appear like curves on the map. So the MapKit handles these curved straight lines by a geodesic polyline, which is not available in SwiftUI. So if you want to plot like the route of a plane, for example, over very large distances, you'll get a straight line which is very different from how it would look if you the actual route of the plane. Okay. Another thing that's not available is overlay renderer, which is some features that are available to you that you can customize how overlays are shown. So for example, we have the overlay that I showed you earlier about like the route of the bus. You can configure things like what's the end look like, is it rounded, is it straight, the thickness and all that, which is much harder or impossible to do in SwiftUI. Another thing is multi-polygon and multi-polyline. If you want to draw, for example, if you want to draw like a building, like the area of a building, and you have multiple buildings and you want to group them together, in SwiftUI you have to have all of them separate, but in UIKit you can combine them together for more efficiency. You can't do that in SwiftUI. So yeah, that's all I wanted to share with you today about MapKit and SwiftUI. I hope you learned something. I learned a lot of this through using like resources online and by Apple documentation, so I'm very happy to be able to share that with you today. Yeah, thank you very much.